upon the unifying theme for mathematics is that math is a language. Okay, math is a language of science, technology, engineering, accounting, manufacturing, and management. So usually we say STEM, science, technology, and engineering, and mathematics. But I think, and actually I put that up on the board one time, and a girl during between classes went up there, and I guess her mom's an accountant. She wrote the accountant up there to her accounting. So I expanded it then to being more than just the STEM and put it. So it's a language, which means that it has words, just like a language has, which we call terms. It has phrases, which we call expressions in math, and it has sentences, which we call equations or inequalities in mathematics. So it is a language. However, when we come to, if I draw this and I put math word problems, any feelings come to you when you see that word, solving a math word problem? Yes?
Fear.
Fear.
Okay.
Fear. Right. Okay. Any other ones you get? Yes.
Challenge.
Challenge. You're going to give me hard words, huh?
Daunting.
Okay.
Daunting. Tears.
What?
Daunting. Tears. Oh, that's
Daunting.
Tears. Confusing.
I don't know how to spell these words.
Confusing.
Confusing. Okay.
I hate word problems.
Hate.
Did I hear hate?
Yeah.
And remember, it's a Catholic school, so we don't want to say any words that are not that are vulgar. And,
Tears. Tears.
Which one?
Tears.
Tears. Okay.
Tears.
So
Lots of.
when we see that, when we see math word problems, I've often read a math word problem, and usually you try to have a mental picture of what you're reading, and sometimes I've gotten finished reading the math word problem, and I look in my mind to see what's up there, and it's totally blank. I don't know what I'm really trying to solve. So one of the things, if we look in terms of that unifying theme, that math is a language, one of the things we're doing is we're taking and we're translating the English in the math word problem, okay, into another language called mathematics. So that's a translation problem. We have difficulty with that translation problem. So last year, I went to see if I could find some courses that would address word problems, and there are a group that's called Ed2Go, Ed2Go, and I think I actually was looking at UWF and PJC and looking to see what their continuing education problems were, and I kept seeing, or courses were, and I kept seeing this, they both go to Ed2Go, and somehow or another I found the cheapest one, which is someplace up in North Carolina, Community College up there, Piedmont, and they charge you $65 for a course, and PJC and UWF were up in the hundreds of dollars for the same thing. It all goes back to the same company, Ed2Go. So last year I took the course on Singapore math modeling, grades 1 to 6, and then I got all enthusiastic. We bought the Singapore math modeling for grades 6th grade and 7th grade, and my goal was to do 15 minutes a day math modeling. Of course, that didn't work out. We went from block scheduling 70 minutes to 45 minutes or 50 minutes, and 15 minutes is an awfully large chunk out of a 45-minute class period. And so these books are beautifully bound, clean. They do have sometimes names of students in front of them. Some of the problems I found with them is, the first one was they work all the problems out in the back. So eventually the students looking at it know that if they just go to the back of the book, everything's worked out for them, so they never got to work them out. The other thing I found with them was that it didn't have any sequence in it. In other words, you didn't get to work percent problems, you didn't get to work rate problems. all at once. It was all spread out throughout the book. So I didn't get to do that last year through the book. Now I did do it through the classes. When we got to word problems, we would use the Singapore method. All right, so those are the feelings that we have about word problems. And the Singapore methods for math have, does this go to sleep?
Yeah, just hit the little on button by the light.
The one that's lit?
Yeah,
All right. No, the light that's not
and
lit.
the light's over there.
Okay, all right.
And where did you do this, the Northwest Community College?
When I go to take the
Yeah.
classes, Piedmont Community College in North Carolina. Their courses were $65. Matter of fact, the one I took this summer, which was Singapore Math Modeling for 6th through 8th grade, or 8th through 9th grade, I forget exactly what. They had a summer special for $49, so I took that one for $49. It's basically 12 lessons over a 6-week period. So Singapore Math Modeling is one part of the Singapore Math methods that they make use of. Singapore Math methods are made use of they use mental math a lot. They use numbers, especially place values, and then they do modeling for the word problems. So those are the 3 parts, actually, of the Singapore math methods. And to look at a warm-up, our traditional way of approaching this edition of 567 plus 285, we start over here at the right and go 7 plus 5 is 12, carry a 1. 1, 7, 8, 15, carry a 1, 6, 2 is 8, and come up with the answer. In the Singapore methodology they depend very much on place value and then doing it mentally versus crunching numbers on a calculator, which at least I see my kids get more and more. The older they get, the more they want to crunch. What they do is start actually over at the left. And so this is the hundredths place value. So 7 plus 2 is actually 700. Then they come over here, 6 plus 8 in the tens value would be 140. 700 plus 140 is 840. And then 7 plus 5 is 12. So 840 plus 12 would be 852. Yes?
I don't know about Singapore, but my dad was born here in 1904. That's how he did math.
Well, it might very well be because the Singapore really has a basis going back to British, and so it might very well be that the education, it might even, we might trace it back to those periods there. But this is basically a place value, and then using mental math for it. So that's what they stress, say, in the Singapore method. Okay. The other thing we know in math and probably in science, and all the different things, you have to work from the concrete to the abstract. Right? So the concrete might be a pictorial representation here of 2 trees plus 2 trees equals 4 trees. The representation we have is 2 plus 2 equals 4. And then we could get abstract by saying x plus x equals 2x. So that would be working it abstractly. Normally, when we're working word problems, we start out with the word problem, say what 3 numbers, 3 consecutive integers sum to be 51, let's say. And usually what we'll do is we go from that question over here to the abstraction, saying let n be the first number, then n plus 1 is the second, n plus 2 is the third. So we jump that pictorial representation of it. So our normal methods are going from concrete and algebra over to the abstract by specifying what the variable is going to be. So in the Singapore method, they're trying to bring it back to where you have a model of the process that you make use of. It is recommended for students who have problems with word problems or Title I type of students who have difficulty with it because it does have some pictorial representations associated with it. So the step, sometimes you see an 8-step process, and what happens is that this step up here, where you write a complete and grammatically correct answer up in the second problem, which then focuses your mind on what you're trying to solve, is also repeated in the 8th step, where you actually put in the answer here, how many fish the person had in the aquarium. So you'll see a 7-step, and sometimes you'll see an 8-step process. So the first step is reading the problem. I don't know, the students I have, if I have, say, find the area of the circle in terms of pi, and in terms of to the 10th when pi is approximated by 3.14, I very, very seldom get 2 answers. I usually get one answer where they just found the pi key on the calculator, they punched that in, they times it, times what the radius was, they did the up caret, the square, punch it in, get an answer, and then they round it to the 10th position, or they don't round it to the 10th position. But they very seldom really are reading the problem and seeing that it's asking for 2 answers, one in terms of pi, and the other to the nearest 10th when pi is approximated by 3.14. Now, there are other things where you see that they just don't read the problems. They jump right to the working them without having read them. So the first step here is reading the problem and then writing a grammatically correct answer, which is usually the last sentence in the problem in a question format, and they have to take that question and make it basically into a declarative sentence. Right. That focuses their minds on what they're trying to solve for. Then you have to identify the variables, the who and the what's. Okay, who is the person for this, Dana, the name here. What is it? It would be like the fish in the aquarium. So the who's and the what's. Now, initially, in the lower grades, they really stress using the unit bars. As in the 6th to 9th one, they use other things. They might use extension lines and stuff like that for representations. But in the first one, they basically use unit bars. Now you go back and you're rereading. And usually they'll use the term reflectively reading it, reflectively thinking about it. And you go sentence by sentence, and then you start making adjustments to your unit bars to answer, to really put down what the question is, sentence by sentence. Then up here we were showing what we're trying to solve. On the picture, we're going to put a question mark where that solution is going to be. Then you do the numbers, work the numbers and come up with the answer. And then you either put in an 8th step here where you write this sentence and put the answer in, or just come up into this blank space and put the answer there. So it's a logical way of linking the concrete to the abstract by having a pictorial representation of the problem. So let's look at the first one here. Now, one of the problems I had in introducing it, if you're trying to get them to understand the process, you make the problems simple so that they're not bogged down in the process. Unfortunately, there are a lot of the kids who will just say, the answer is 400. They don't want to go through a process. They don't want to go, and some of them are if you do abilities testing, they're way high in abilities testing. When you see the achievement, it comes down. And I think that's primarily because they do not want to spend time learning a process. They just have sort of an intuitive knack of answering things most of the time. And when they come to those times when their intuitive process doesn't work, then they just put any old thing down on the thing here. So here's our problem. So Jules sold cookies for a fundraiser. She sold 90 more in the afternoon and in the morning. If she sold 320 cookies altogether, how many cookies did Jules sell in the afternoon? So that's the problem. If we look at it, first of all, what are we trying to answer? What would be a good declarative sentence for this problem? Yes?
Who, me?
I didn't really
Oh.
have it together yet. Jewel sold blank cookies in the afternoon.
In the afternoon, right. That would be the declarative sentence. So that's what they're trying, that's their goal of working the problem out. Okay, if we come here, this is the same problem repeated. And we would put actually put the question here. We have Jewel sold, we have the unit bars. We put 2 unit bars in here, one representing the Jewel's cookies in the morning, that's the who and the what, and then the other one is in the afternoon, and then those unit bars there. Now we go back and reread the problem. So she sold cookies for a fundraiser, that's not going to change anything. She sold 90 more in the afternoon than in the morning. So we're going to have to adjust this unit bar for the afternoon by 90. So you would attach something to it, put 90 inside of it. And that would resolve the second statement. Then if she sold 320 cookies altogether, now here we use this bracket, or brace, or whatever it's called. Is it a bracket or a brace? Whatever.
Bracket.
That means altogether. That means altogether. Matter of fact, that was one of the methods we had in that class last week. Do you remember?
Yes.
And this meant you had to include everything. Dependency, if it didn't depend upon both of them, you couldn't put it in a bracket. You had to put it in a list. Well, that makes sense here. This includes both of them. They're going to be 320. So if she sold 320 cookies altogether, how many cookies did Jewel sell in the afternoon? All right. So we're going to there. So now we have that, we have this. We're putting a question mark for the afternoon for Jewel. And now we're going to go to the computation steps. So we're looking at the cookies, 320 minus 90 equals 230 cookies. So we're taking off that 90 and seeing that this is going to be reduced to 230. We have 2 units here, 2 units which are the same. So 2 units equals 230. 1 unit is going to be 115. So then we go back into the afternoon, would be the 115 plus 90 is 205. So then we would go back and write Jewel sold 205 cookies in the afternoon. That would be the answer to it, right? Do you see that concept? So you're trying to, instead of saying let this be x and this be x plus 90, and that would be x plus 90 is 2x plus 90, subtract 90, you're going to come out with the same mathematics, but you don't have a visual for them to grab onto. You're actually just jumping from the concrete problem to the abstract. Does that make sense?
Mm-hmm.
Okay. All right, here's another, this is a part whole. So we have, and these are problems in, I don't know if they're in that worksheet, but, okay. Jim, you want to read the problem?
2 pounds of apples and 1 pound of pears cost $3.15. 2 pounds of apples and 3 pounds of pears cost $5.65. Find the cost of 1 pound of pears.
Okay, so these are the types of problems where after you get finished reading them, you look up in your brain and see what's written on your slate up there and nothing's there. All right, so this is where it becomes helpful. You're going to focus on, first of all, what am I trying to answer? Jim, what am I trying to
I'm
answer?
trying to find out how much 1 pound of pears cost.
Okay, so 1 pound of pears cost, so we write that down. Now, as I said in the lessons that she used for grade 1 through 6, she followed that process very, very strictly. When they get to the second course, then they're a little bit looser in it. So here we're just sort of taking that first question 2 pounds of apples and 1 pound of pears cost $315. And we're going to represent the 1 pound of apples here, 1 pound, so that's 2 pounds of apples, and then 1 pound of pears. But we're represented by bars, yes.
But you don't know that it's necessarily the same for the apples and the pears. You put apples, apples, pears as if each
Oh, it says,
usually cost the same amount, and there's
Oh,
no.
no, it's
real-
No,
boxes
no.
bigger.
these are apples and apples here are the same box size, but the pears I have a
A little
different
bigger.
size box.
Okay, and that's the visual clue to the students that they know that pound of pears is not the same price as a pound of apples.
Right.
Because it doesn't say it anywhere.
No, it doesn't. You could actually make this one smaller. You're just trying to make it different. Or a lot of people use colors. So they would color the apples as red and the pears as green or something like that. So they could use colors to differentiate it.
Okay.
Then you go to sentence 2. 2 pounds of apples and 3 pounds of pears cost $5.65. So again, we have, fortunately, 2 pounds of apples, so we put them there, and then 3 pounds of pears. All right? All right. And then their total cost, I really should have a bracket here showing that the sum of all these costs here are $5.65, like it is up here. Now those brackets can go on the side or on top, however you want to put them. Okay, now when we take a look at it, you can notice we have things that are alike. The 2 pounds of apples and the 3 pounds of pears, and that's $3.15. So coming right down here, these are going to be the same. You can't see it on the bottom, but you have, and that was what, how much was that?
$3.15.
$3.15? Okay, and how are you doing that? All right, now we have and they said that was what,
65.
65. Okay, now you notice that these things are the same. These things are the same. So, that means in our computation step, we can take away $3.15 from the $5.65. Does everybody see that? So we have the 2 pounds of apples and 1 pound of pears, 2 pounds of apples and 1 pound of pear. They're common to both of them. They're sort of like a common unit in both of the representations. Right? Now what's then left here is the $2.50. Okay, so now, and they usually break out using like A's and B's when they're doing different steps. We have now here 2 units of pears. 2 units equals $2.50. So 1 unit equals $1.25. Right? Does everybody see that? That was sort of down on below here. Everybody got that? Okay.
There it is.
All right. So that's at the bottom. And you can see that it comes out to be 1 pound of pears cost $1.25. Now you should have a problem in the worksheet there about baseballs and bats. And you'll notice that it sort of tracks. This is not here. This is in the problem sheet. Practice problems, the first page. And you should have a separate page which has the model drawing process broken out, so if you needed to do it. Let's go through this one first of all. Read the problem carefully. So we read the problem, 2 baseballs and a bat cost $75. 2 baseballs and 3 bats cost $215. Find the cost of 1 bat. So now what we need to do is write a complete grammatically correct sentence about the answer you're seeking. And that would be, what would be a good grammatically correct statement for the answer?
1 bat costs blank.
1 bat costs blank dollars, okay, or dollar. So that would be the complete grammatically correct sentence. Identify the variables, the who's and the what's. Well, these are basically, I would just be called what's. You could have who's and what's and both together or just separate. But, so we have baseballs and bats. Those would be the variables. So, everybody with me so far on that? And then the next step would be write them down in the order they appear in the problem. So we're going to be doing this 2 baseballs, maybe you should make them smaller, huh? Because baseballs are usually small. So 2 baseballs and a bat, and that costs $75. So 2 baseballs and a bat cost $75. We could do, no, the other way.
Yeah.
Okay, and then 2 baseballs and 3 bats, so it's basically the same problem as before. So a ball, bat, bat, bat. Okay, so 2 baseballs and 3 bats cost $215. Okay, find the cost of 1 bat. So we could put a question mark above that 1 bat. So no, that's what we're looking for. Right? Does everybody see how you can work this out? And it tracks the previous problem pretty closely. All right, now you're ready to do the computation. We notice we have 2 balls and a bat, the same thing here. So that's the units that are the same in both of them. So we can take away from $215, we can subtract $75, and that comes out to be what? 140? Is that right? Okay. So $140. All right, now again, that actually is for this area here. If I could write brackets appropriately, that would include those 2 bats. So now I have 2 units, the 2 bats, is equal to $140. 1 unit or 1 bat is equal to $70. Then I can go back into my question, the statement I have at the goal statement. 1 bat cost $70. 1 bat costs $70. Does this make sense?
Yes.
Okay. Okay. All right.
Like on the test, we can figure out how much of the ball.
Sure.
So again, what you're trying to do is bridge that gap between the concrete and the abstract by having a representation in the middle of it. Okay. All right, now we get into a comparison. And these are actually all problems that are in the course. Okay, so Tippy, Delaney, and Haley have a total of $580. Delaney has $120 more than Tippy, and Haley has $190 more than Delaney. How much money does Haley have? Okay, this might be another one of those questions where you get finished and you look up there and there's a tabula blank. All right, what am I doing? So what we're going to do is form the grammatically correct sentence, Haley has so much money, because that answers what they're asking. That answers what they're asking.
Do we have this one? I don't think we have this one.
It's on the,
It's on the slide.
PowerPoint.
It's on the PowerPoint, and then there'll be hopefully the practice will track it, or be close to it, or might be a little bit differently. Okay, so,
You just went, yeah, there you go.
all right, does everybody see this then? So now we're identifying the variables. Tippy's money, Delaney's money, Haley's money. Here's the who and the what's. So this is a good example of the variables representing who's and what's. Here's a good example where the unit bars are all the same. Okay, you start out with the unit bar. This is a composite of many steps being done. Your first step is writing, Haley has so much money, because that answers the question of the problem. The second step is identifying the who's and the, well, it's actually the third step, identifying the who's and the what's, putting a unit bar down, and now you start rereading, or they say reflectively reading, the problem again. So Tippy, Delaney, and Haley have a total of $580. I come over here and put the bracket, put 580. That bracket represents the sum of all of them, okay? The sum of all of their money is 580. Now we see, Delaney has $120 more than Tippy. So here's Delaney, here's Tippy's unit bar. We put another little bar on that, which shows the $120. And then it says, Haley has $190 more than Delaney. So here's Delaney's money, and then $190 more than that is what Haley has. Okay, so let's go through that again. The unit bars, they start out with the same unit bar. Delaney has 120 more than Tippy, so that 120 is answered or added to it. And we're flowing through the question, step by step or statement by statement or phrase by phrase. Then we come to Haley's money is $190 more than Delaney's, so we have to add on another little bar to it with $190 in it. Okay? Now we have how much money does Haley have? So this is actually inclusive. I should really put a bracket here showing that it includes them. So that should be there to show that it's really going to be the sum of this unit, 120 and 190, which will give me how much money Haley has. All right? So now let's start working through the problems. We're going to be taking that 580 that we know, and we're going to be taking off, or actually they're summing up here, the 120, there's two of them, plus the 190, that becomes the $430 identified here. We're taking that away from the 580, which gives me my 150. So now I'm back to the 3 unit bars over here. They're all the same. So we have then, if we went to a C, 3 units equals 150. 1 unit equals 150 divided by 3, or $50. Okay. Now, am I finished?
No.
No. What is the question asking for?
Haley.
How much money does Haley have? So my next step here is D. I'm going to be adding up the 50 plus 120 plus 90. And what does that come out to be?
190.
2 what?
It's $190, not $90.
No, 100 now. Okay, good. That gets even bigger. All right, so what is that going to amount to be?
36.
So it's a 0, a 6, and a what?
360.
36.
3?
360.
360? Well, let's go. Sum of the digits. 3 plus 6 is 9. Okay, 5, 6, 2 is 8. plus 1 is 9, and 9 cancels out. Okay, so that 360 is the answer to it. Any questions on that? Okay, so that's the way you would do, I'd say a little bit more complex problem. And so let's look at, now we have Samantha bought a coat, a pair of shoes, and a bag for $242. The coat cost $71 more than the shoes. The shoes cost $27 more than the bag. How much did the coat cost? So this is really a similar problem to the one we did before. And that should be in your handout.
Yes, it is.
Okay. So I'll go back to the comparison problem with Tippy. And you can see that the first step is identify you read the problem. The second step is identify what's being looked for.
The code.
Okay, so, and you have to write a grammatically correct sentence. The coat, Haley's coat cost blank dollars. Okay, so that would be how much does Haley, okay, I'm sorry. How much did the coat cost? Samantha's coat cost so many dollars. That would be the grammatically correct answer we're looking for. Okay, next we're going to be doing is identifying the variables. So what are the who's here? Who's the who in this?
Samantha.
Samantha. What's the what?
Coat, shoes,
Coat,
bag.
shoes, and bag. So we come over here with Samantha's coat, shoes, and bag. And then next, you put the unit bar for each one of them. So you put the unit bar for the coat, the pair of shoes, and the bag. Right, so once we have the unit bar down, now we go back and reread the problem. They say reflectively reading. So the first sentence, Samantha bought a coat, a pair of shoes, and a bag for $242 altogether. So I put a bracket and the 242. So initially I would have these 3 unit bars here, the bracket, and $242. I go to my next sentence. The next sentence is what? The cost of the coat cost $71 more than the shoes. So here's the shoes, here's my coat. I have to add something on here which shows that this coat is $71 more. Right? That's that one there. The next phrase, while the shoes cost $27 less than the bag. Well, you can work that in 2 different ways. You could start coming into the shoes here, $27, or you can add the $27 to the bag, which would be the same, and preserve your unit bars all being the same.
And would you suggest that your students?
I preserve the unit bars being the same because it makes it easier when you get down to the end. You say 3 units equals.
Yes.
It's easier at the end, but is it easier for your
Well, that's what you
newer
have to
students
think.
to know that adding to the bag is the same as subtracting from the shoes? Do you see my point?
Well, you can explain to them that adding is, in a comparison, adding to one is the same as taking away from the other. But I think you'd want to say, if I'm going to be adding here, I should try to maintain that process throughout it. Even though eventually you could come to the same answer, but when I think about it, I don't know what I would have done in here, not knowing what percentage of a unit that was going to be. Well, excuse me, up here, if I took $27 away. But I know I'm preserving my units being the same when I add the $27 down there. Does that make sense? Okay. So then while the shoes cost $27 less, so the bag costs $27 more than the shoes. So we put that in there. And again, we're going to coat cost. So we put our question mark here to show us and this should actually have a bracket, meaning that it includes all of the cost. The unit here plus the $71. Right? Okay, now, we're summing up the money we know, 71 and 27, getting to 98. We're taking that away from the 242 in the next step to get 144. And now we have 3 units equals 144. 1 unit is going to be equal to 48. Is that right?
Yes.
Okay. So each one of these units here now is, each one of these units is now 48.
The hardest part of this problem is the 27. Where to put the 27, and you gotta kind of use backward logic to figure that out. You gotta get them to that point.
I always had so many students that would stop right there at 48. It's
Me?
just like, the students would do just what you said.
I know.
Get
Because they
48
stop right
and
there.
not read the question.
Okay, well that's one of the things about writing this grammatically correct answer up here with a blanket in. So this, the question is really over here. So visually they see that's the question. The bracket saying includes both of these. So they know they have to go to a D step right down here, which is add 48 plus 71. And that would come out to be what, 119?
Yeah,
Okay. So then they can,
I do.
all right?
Bravo.
Does that make sense?
That makes a lot of
Makes sense.
sense.
Don't you have 118 down there and shouldn't it be 119?
Oh,
What, Julie?
that's just an error in mathematics, that doesn't matter.
Oh, okay.
Don't look at that down there.
What did I do? Say 118?
Yeah,
Look
don't
at
look
the
at it
man
down
behind
there.
the
Okay.
That word started confusing.
Actually, he put that up there to see if you were paying attention, right, Mr. Henley?
No, actually, I messed this up when I first did it.
I'm honest for a bunch of 8-years.
No, all right, good. Okay. Okay. Questions on that?
Do one of the ones where the train's coming from this direction and the train's coming from that direction, and those are the ones that I start going, I think I'd like to be using it.
Yeah, well, you say that to the last, hopefully you're all asleep by that time. When ask questions. Okay, so that's comparison. We only took out about 4 or 5 different ones, but there's a lot of different types of word problems. Okay, the next one is the before-after. Okay, Julie, you want to read it, the before-after one? Yes.
Mike had 165 coins in his collection, and Dolly had 75 coins in her collection. When they each collected an equal number of coins, Dolly had half as many coins as Mike. How many coins did they each collect?
Okay, again, this is a problem.
Yes, it is.
And it's called before and after. And you have to sort of, and you look for key words. You're looking for words that'll say, like, are these good?
I don't get it. Equal number of coins, but she had half as many? Oh,
No, okay, before and after. So Mike had 165 coins in his collection, and Dolly had 75 coins in her collection. When they each collected an equal number of coins, there really should be something like after.
Yeah.
After. That should show a change in time. Now, that's probably, I didn't copy the question correctly. But it should show after they each collected an equal number of coins. So that gives you the after portion of it. Dolly had 1/2 as many coins as Mike. Now, this is a little magic. It's not as straightforward as the others. What they basically did in this one is they know this, they don't know that. They know they're going to add an equal amount to 165 and to 75, and once they do that, then this is going to be half of that. Okay, now here's the magic, and I don't think there's a good procedure for it. Is they go down here and they find the difference. They take 75 and double it, and that gives them what?
150.
150.
150, and then they find the difference from 165 to 150 being 15, and then they add 15 to both of the after numbers to get the 180 and 90. Now, I think this is a little bit of a magic because I don't really see crunching of numbers down here, which makes sense to me. But they're taking the 75, they're doubling that, and then they're saying, okay, when I double that, what is the difference still from 165? And that's going to be 15. Now I add 15 to both of these, and that comes out to be 180 and 90, which is a half. Yes.
Well, using this method is confusing, but if you went back to algebra, and they said that she has half as many coins as Mike, for her to be equal to Mike, she has to multiply her coins by 2.
Right.
And that's why they got the 150. 75 times 2 is 150.
Right.
And then she's still going to be short to make it equal that 15 coins. And that's why they doubled it.
But okay, right. But once you, yeah,
Because if you did it algebraically, you would put.
I think if you did algebraically, you really have problems, to be very honest with you. Because if you let this be x and that was 2x, then I don't know how you would incorporate your 165 and 75 into that. You'd have to say x is 75 plus something or other. Anyway, this is probably one of those where you do them enough till you see that there's a trick here in finding before-after problems. Yes.
All you would do is pay x plus 75
Yes.
equals x plus 165.
And then 2 times that.
Yeah, and then 2 times
Oh,
that.
beautiful.
And then
Yeah.
you'll have, that's the algebraic way, which to me makes more sense because I'm not Singaporese. But I liked everything up to this point.
Okay.
This one's
All right.
check for me.
What Jim is saying, if we went to it algebraically, in other words, jumped over the abstract,
Concrete to abstract.
representation, that this is twice here, which is x plus 75, it's beautiful, yeah. And then up here, this is x plus 65, and solve that. That would give you your 2x plus 150, and then take away 150 from both sides.
That's so much easier.
But see, all these things, they work really well for certain things, but other things are.
Dan, this one, the algebra in that one is much easier for me to see
It
than
might
the
be.
representation for this
Yeah.
one.
Yeah, okay.
But anyway, but it gives you
but-
2 different ways to look at it.
Well,
And you can explain why you double dollies by doing it
by
that way.
doing that, but that is though jumping to the abstraction. Yes,
I said
You must love this, right?
double 75 and just subtract it from 165 and got an answer right there. I
This
didn't
is a
do
dolly
it.
part.
Well,
But then it may not work on the next problem that I work with. You know?
well, I don't know if I did put a before after one after. kind of thing.
Dear God. 2/5,
There,
2/5.
okay, well, here's a before after on the next one on the
Okay,
page.
okay.
Hey, which one is that?
Connor and Mitchell saved different amounts of money. The amount of these was 200 after Connor spent 2/5.
All right.
2/5, that's just a fraction.
Something 40%,
Now-
you can handle this.
Okay, this actually is easier than the previous one, although it might look more complex. Okay, and would you read the problem?
Sure. Connor and Mitchell saved different amounts of money. The total of these amounts was $200. After Connor spent 2/5 of his money and Mitchell spent $60 of his money, they ended up with the same amount of money. How much money did they both have in the end?
Okay, well, they actually do it differently in the book than what I have here, but let's look at the answer. In the end, Connor and Michael each had blank amount of money. That thing is there because I have the answer up there. Okay. So let's look at the variables. Connor's money and Mitchell's money. And we go back and read. The total of these amounts was $200. So we have a long bar here, a long bar, and $200, right? Now, the total of these amounts is 200, so we have the bracket. Now, after Connor spent 2/5, now at that time, then I'm going to take Connor's bar and break it into 5 parts. Okay, take Connor's bar, break it into 5 parts, and then I'm going to line out those 2 parts. Because now he spent 2/5, this is what Connor spent, those 2/5. Okay. And Mitchell spent $60, so I don't know how many bars that is, but I just put the $60 in there for what he spent. They ended up with the same amount of, okay, it says, and Mitchell spent $60 of his money. So this was Mitchell's money, and I just marked $60 there for what Mitchell spent.
But you don't know for a fact that they're
I don't know.
actually equal.
No, not until I get to the next
So you
phrase here.
Could you have not made them the same length then?
Well,
Your
Well, the
picture,
first 3 are the same length. We don't know what Mitchell could be smaller or
right,
bigger.
so
Right.
what we're saying is, would it have been easier if you'd not made them the same length, the 60
See,
and
I
the
would
other?
be concrete,
No,
it would
because-
make me mad that those were the same length.
No.
Well, but
It
then
looks
the
like,
other-
it doesn't have to be the
There's
same
no-
length.
doesn't have to be the
I
same.
actually drew mine, Mr. Hanley, a little bigger so that I would know that they wouldn't be the same length.
Yeah,
And where
And
did
then-
you get 8 units as opposed to 6?
5 on the
Five.
top,
okay,
three.
let me show you.
3 on the bottom.
Okay, if you extended this out, which is probably a good, you could do that,
Right,
or
here
made it
across the
smaller or larger, that would show that they're not the same. Otherwise, we might be leading the kids to say 2 into this
Yeah,
would
yeah,
be
yeah.
100,
Exactly.
therefore that's $20 each.
Exactly.
So that probably is a better way of bringing it in. All right, now, once we've done that, we look at the total amount of money they had, $200. We know what Mitchell spent, 60. So that 200 minus 60 is 140. Now, I took 8 units, and the 8 units come from this. Connor has 5 units up here, and we know that they ended up with the same amount of money. So going down here, Mitchell ends up with 3 units, the same amount of money that Connor ended up with. Does that make sense?
Yes. Yes.
Yeah.
So, okay, Connor, I have Connor broken out into 5 units, okay? And then when I take away the $60 that Mitchell spent, they end up here
Oh, okay.
with the same amount of money. So that's 3 units down here, and then 5 units up there, because I don't know what this spent is. It just says 2/5. So I included that. Then I get 8 units equals $140. Divide both sides by 8. 1 unit equals $17.50. So each one of these units,
So he spent 35 on the other kid spent 60? Because the spent part, I have that second next.
okay, each one of those units is $17.50. Okay, now I have to go back and see, what are they asking? How much money did they both have in the end? So we're looking at, in the end, they each have 3 units. So I have 1 unit equals $17.50. So 3 of these units will be 3 times that, or $52.50. Okay. Does that make sense there?
Actually, yeah.
That's a before-after problem. And all I did actually is I wrote the $52.50 up here in white. So I have to just come back and go over the color. All right, let's just go through that again. So it's a little bit different before after problem than the previous one. Okay, so Connor and Mitchell saved different money amounts. So that's probably why we should make one of the unit bars this way and the other one a little bit different in size. The total of these amounts was $200, the bracket $200. After Connor spent 2/5, so we have Connor spending, we take what Connor has and divide it up into 5 units, and then 2 of those is what he spent. And Mitchell spent 60. We're not sure how that relates to the units, but it's $60, we know that. They ended up with the same amount. So here we have the same amount of money. How much money did they both have in the end? So our question is, or our grammatically correct answer is, in the end, Connor and Mitchell each had so much money. Okay, then we go and we take away what we know in terms of the money, 60 from 200 to give us 140. And then I see 5 units up here, 3 units down here, and those 8 units should equal to $140. So each unit should be $17.50. And now I'm going back and say, in the end, Connor and Mitchell each had. So I have to find out what 3 units is. So 1 unit is $17.50. 3 units would be 3 times that, or $52.50. All right, so then I'd go back up here and I'd say, in the end, Connor and Mitchell each had $52.50. Now, I would suspect that this as a word problem would be very difficult for our 8th graders. Even I think 8th grade honors, they have problems with word problems like this. All right, questions on that? Are you ready to stop for a while or stop permanently? Or?
Can we have a 10-minute break or 15-minute
Okay,
break?
yeah, that way. All right.
Let it vegetate and sit there. This is why I teach English.
Well, I'm writing it now, but I'm not getting the right answer.
Where's Lindy going?
Did you turn the audience?
Oh, the camera? I don't know how to.
You need to.
Oh.